Welcome to a session on number system. In the previous one, we have already taken up portions on rational and irrational number. Herein, we begin with rationalization and application of algebraic identities there. First, I would better give certain identities which will help us in rationalization, that is root over of a square is a. When we are multiplying a root a with a root b, a, b here all being real numbers, that makes us give a be multiplied to b. Similarly, it is also further division, that is root a by root b can also be expressed as whole root over f by b. Then it is root over of a plus root over of b minus root over of multiplied to root over of a root over of b. Now this is a plus b, a minus b, that makes it like a square minus b square, and that makes it a minus b. So root over of a plus root over of b multiplied to root over of a minus root over of b would give us a minus b. Now the next one being a plus root b, a minus root b, so that also is a square minus b square, so that makes it root b square, so it is a square minus b. In case we have root over of a plus root over of b, or in case we have root over of a minus root b whole square, so it will be a square, that makes it a, because root a square is a, plus minus 2ab. Now root a root b can be represented as root ab plus root b square, that makes it b. And the last one here is root a plus root b multiplied to root c plus root d will be root ac plus root ad, ac plus ad plus root bc, this multiplied to this, plus root bd. Now based on this, let us take up few questions. We are supposed to take up of 243's fourth root by root 3's fourth root. Sorry. We have written previously that root a by root b can also be expressed as whole root over of a by b. So in this case, a by b is 243 upon 3. Now 243 upon 3 is giving us 81. So fourth root of 81 I think is 3. Now we take up another type of such question, wherein we will need the application of the identities, like 5 plus root 7, trying to relate to the identities which we discussed in the previous screen. Here it is a plus b into c plus d. So we will multiply ab, that's 5 into 2 plus 5 into root 5 plus root 2 into root 7 plus root 7 into root 5. This gives us like 10 plus We cannot add these two, so they'll remain as they are. Root 7, root 5, so it is root a into root b gives us root ab, that makes it root 35. This is application of the last one, identity. We can take one question here on the screen. I use a different color here. We can easily make out. So this is quite visibly a plus b and a minus b. So we had taken a square minus b square, and it will give us a square minus b square would give us 25 minus 5, and the answer becomes 20. Let us take up the one of those, a plus b whole square, a minus b whole square, and one of the questions we take up here. I write it. I'll take up both. One is a plus b whole square and the other one is a minus b whole square. In that case, it is a square plus 2ab plus root 2 square, that is the b square. So this is 5 plus root 5, root 10 would be 10. So it is root 10 to root 10 plus, this is square root of 2 whole square is 2. Sorry, and the answer that makes it is 7 plus 2 root 10. A similar question can also be taken up for a minus. Not much will change. If I keep a minus here, this symbol will get minus and the rest of them will remain the same. So the answer will now be this if I am taking a minus symbol here. So I am not taking a question separately. That one will explain you. Next part is, this is about identities, and the next part being the rationalization of the denominator. In such case, we come across, not in such case, I just wanted to say, sometimes what happens, we come across expressions containing square roots in their denominators. In that case, it becomes difficult if we have the denominators in square roots. So it's better to remove the denominators with square roots and that thereby multiplying it by a factor. And when we do so, this whole process of removing the square root in the denominator calls the rationalization. Now I just take up a very small example before moving on to questions which would make you do the whole question. Like, look at this one. You have a root here in the denominator. We would prefer the removal of this root. To do so, now as because it has a root 2 in the denominator, if I can multiply a root 2 in the denominator, that would make root 2 multiplied to root 2 gives me a 2. So when I multiply the denominator with the root 2, so do so I have to do the same in the numerator as well. So I'm sorry. So in the numerator it becomes 3 plus root 5 multiplied to 2. So that makes it look like 3 plus root 5 multiplied to root 2, and in the denominator it has already become 2. So in the numerator it becomes 3 root 2 plus root 10 by 2. This is how we have removed the square root in the denominator. In more questions we take up further. I take up 1 by, numerator has only 1, the denominator has got a root which is 7 plus 3 root 2. We need to think how we can rationalize, that means how we can remove it. Now the rule says, there is a rule in the sense, you can remember that if we have to rationalize any number like 1 by a plus minus suppose root b, then if we have to multiply the whole fraction by the opposite of this, if it is a plus root b in the denominator, we multiply the whole with a minus root b in the and oppositely, if it is a minus, we multiply with a plus. So in our case, we have a 7 plus 3 root 2, that is a plus root b, so we multiply a minus root b both in the numerator as well as the as well as in the denominator. So that would make me get 7 minus 3 root in the numerator, and in the denominator we have got 7 plus 3 root 2, 7 minus 3 root 2. So that makes us 7 square minus 3 root 2 whole square. So it is 7 minus 3 root 2 by the denominator becomes 7 minus. Now 3 root 2 into 3 root 2 makes it 4 into 9, that is 36. No. Sorry. Root 2 into root 2 is 2. 2 into 3 into 3, that is 9. It is 18 I'm getting. So the numerator will remain as it is, because our main concern was to remove the roots in the denominator, and I'm getting here as 31. Let us take up one more such question here. 5 by root 3 minus root 2. Now as because we have a denominator negative, we would prefer taking up a positive there in the numerator to rationalize. I'll do so in the same step. So I'll get this by root 3 minus root 5, and the numerator thereby I'm getting a 5 multiplied to root 3 and root 5, and in a denominator it becomes I'm getting a denominator with I have to multiply it with a plus. So it is root 3 whole square minus root 5 whole square. So in the numerator it will remain as it is, and the denominator would then become 3 minus 5, that is minus 2. So the answer can be written as minus 5 by 2 multiplied to root 3 plus root 5. We take up more such questions in rationalizing. It says simplify each of the following by rationalizing. How do I write? Simplify by rationalizing. Simplify by rationalizing, as because now we will be getting into more the numerator will not be getting it. Okay, I was just considering taking a few questions that I kind of mumble there. Take this one. I think that is a there are many such questions in the past papers as well. This needs to be rationalized. To do so, what do we multiply this with? We multiply this with 2 root 2 minus 3 root 3 by, again the same thing I write here. We learnt we oppositely multiply the opposite of this, minus 3 root 3. So in the numerator we are getting 2 root 3 multiplied to 2 root 2. 2 root 3 multiplied to 2 root 2 would give us 4 root 6. Again 2 root 3 multiplied to 3 root 3, that gives you 3 is 3 and 6. So 3 6, I think I'm getting an 18 there. Again minus 5 multiplied to 2 root 2, that would give us a 2 root 10 there. Again minus 5 multiplied to minus 3 root 3, so that becomes plus 3 root 15. In the denominator, as such, I'm getting a plus b, a minus b, so that makes it 2 root 2 whole square minus 3 root 3 whole square. The numerator would remain same with no solution further. Just I'm writing it down. By, now this makes it to 4. 4 into root 2 square is 2. 2 4s are 8. Minus, I'm getting 3 root is again square is 3. 3 3 9. 9 and 3 is a 27. So I'm getting I'll just write it there. Here I will write it here. So I think 4 root 6 minus 18 minus 2 root 10 plus 3 root 15. I need to erase this part, yeah. By minus 19. To remove the minus in the denominator, I multiply the numerator and the denominator both with a minus. That would make us get of minus 4 root 6 plus 18 plus 2 root 10 minus 3 root 15 by a 19. We can also rearrange the numerator and write the answer as 18 plus 2 root 10 minus 4 root 6 minus 3 root 15 by 19. Hope you followed this. Thank you.